Welcome to the Basics of Profiling Level 3. In this video, we will be focusing on a more in-depth analysis of the profile results and optimization. In this training video, you will learn how to analyze the profile data that we have collected from profiling our thermal process. Upon completion of this training video, you should be able to analyze the kick thermal profile data, manage your profile graph, and Master Navigator, the process optimization tool. In Basics of Profiling Level 2, you learned about setting up, running, downloading your thermal profile, and a brief explanation of PWI and where it comes from. In this lesson, we start by analyzing the profile graph data in detail. At the top of the window, you will see date and time, indicating the date and time that this profile was completed. Slightly below the date and time, you will find your product name. Below the date and time section is the thermal profile plot. The profile is plotted in a temperature versus time graph. Notice the different zones of the oven indicated by vertical lines. Notice original temperature readings for this profile represented by the bold plot line and dotted line representing the predicted profile values. We will discuss prediction later in this training video. Below the graph are several tables. The first table shows all the process values defined for this product. In this case, max rising slope, soak time, reflow, and peak temperature. We will cover these parameters and the overall process window in a few moments. In the same table, the first section is related to the readings for this profile that we just did. The second section is based on the predicted values. In each parameter column, you will also be able to find the delta T between all the different thermocouple values. The last table represents the different temperature and speed set points and is divided into two different sections, the original recipe and the predicted one. The first section of this table shows the recipe that is currently loaded on your oven. These are the set points that were used during the profile that was taken with the 63% PWI. The second section is related with the predicted set points. This prediction works either manually or automatically. So if you change any of the set points, for example speed or zone temperatures, the software will show you how these changes will affect your thermal profile. You will see the changes in the PWI value and in the graph plot shown above in the dotted line, as well as how these changes affect different parameters of my process window and the predicted values. Using the profile as an example, the prediction function of the profiling software 2G is indicating the PWI can go from 63% to 95% if you manually change the zone 8 temperature to 250 degrees Celsius. Now that we have covered all the different profile sections, we will now briefly cover how to define and edit your process window. In the bottom of your screen, you will see three buttons in the center. The far left of these three buttons is Define/Edit your process window. This is the same feature you access from your PS2G main screen to define or edit your process window. The second button from the left will allow you to copy the profile data to clipboard. The third button from the left is the Print button. This will allow you to print a report of this profile. Please click on Define/Edit Process Window. In this menu, we will define our process window based on the specifications provided by entities such as your solder paste provider, your customers, or even internal guidelines from your company. These specifications will be limits to our thermal process that will define out-of-spec situations. PWI stands for Process Window Index and is a method for quantifying thermal profile performance with one single value. Now we will show you how to edit your process window. Please click on the second button from the left. In the drop-down menu, common parameters for our industry used to define your own process window can be found. We always try to have this library updated following the industry standards and our customers' requests. Based on your specifications, you should select the parameters that you will use for this product and then define the limits for each of them. In the example, we are using max rising slope, soak time, time above reflow, and peak temperature. Using time above reflow as an example, the specification for the product is to be above 217 degrees Celsius for 45 to 75 seconds. Outside of this range, the product will be out of specification. PWI is giving a percentage to the upper and lower limits of positive 100% and negative 100%, respectively. In this case, 75 seconds will be a positive 100% PWI value, and 45 seconds will have a negative 100% PWI value, while the middle of the process window will be 0% PWI. In this example, 0% PWI is 60 seconds of reflow time. Therefore, any deviation from the middle of the process window will be represented by the corresponding percentage of the PWI value. Looking at the thermocouples readings attached to these two components, DIP and BGA, we see they are inside specification, but also know that DIP is closer to the limits, while the BGA is closer to the center of the process window. Double mouse click on the top of the graph. This will allow us to expand the graph for a more detailed perspective of the zones and thermocouple alignment. In this example, the two thermocouples do not begin to heat up at the same starting point. This happens because of the different positions on the board or even because of the thermal inertia, but we can improve the alignment of the two TCs using the graph tools in the Kick software. Right mouse click on the graph as shown in this video. A small window will pop up. Please choose Move TC Line from the menu in the pop-up window. In this example, watch how the Move TC graph tool is used to move the TC's alignment, in this case TC number 2. If we have more TCs, we should align the remaining ones based on its position. It is even more evident that the zones in the graph are not correctly aligned after the thermocouples are properly aligned. To move the zone lines, please right mouse click again on the graph. In this example, we begin by bringing the start of the first zone to match in the graph where the temperature starts to rise. If there is still a need for a fine-tuning of the beginning and the end of the profile in the same pop-up window, we can choose to individually adjust the first or last line by choosing Zone Resize. There is always the possibility to reset any changes to alignment that were made. To reset the graph to the original alignment, right-click on the graph again and choose Reset. You'll be able to choose which change you would like to reset. To conclude this part of the profile graph management, let's use the two graph plots shown on the video as an example. The top graph shows a profile with bad alignment of zones as well as TCs. An offset of the TCs is clearly shown and needs to be fixed. Bad zone alignment is also demonstrated here and here. Correcting all the misalignments, the graph should look like the one below, where all the TCs align perfectly as well as the zones. If for some reason during your profile one of the TCs came loose and is now reading the air temperature, you can always disable it if you do not think it is critical for this product. This will allow you to properly align and have good readings without the need of running a new profile. Just left mouse click outside the graph plot as shown in the video and disable it. Now that our profile has been correctly aligned, it is important to know that this proper alignment will have an important role in the ability of Kick software to predict and optimize a new recipe. The Navigator Process Optimization tool can automatically calculate an optimized solution for the profile process requirements respecting these three parameters. Minimizing PWI, used for better quality in our products among other benefits. Maximizing conveyor speed, maximizing volume of production. And lastly, minimizing energy consumption, used to save energy in the company daily tasks. For the purpose of this video, we will only focus on one of these parameters, being minimize PWI. Like mentioned previously, by minimizing the PWI, we are aiming for better quality by being in the middle of our process window. This will provide us a bigger buffer during our productions and when the oven is regulating itself, so we do not have the risk of going out of specification. When optimizing PWI, there are different constraints that we can apply. For example, if I don't want to change the temperature set points on my oven, I can uncheck the box Allow Zone Set Points to Change, and Navigator will only be optimizing my profile regarding the conveyor speed. It can also be done for an individual zone. Unchecking the box Allow Conveyor Speed to Change will have a similar effect but without changing the speed. You can also put limitations on the changes for conveyor speed. You can choose the minimum speed that you would like to produce, or you can even limit the maximum speed of production as well. Now that we have defined all our optimization constraints, let's apply the changes and check for the improvement on our profile. Based on the results given by the Navigator tool, we can lower our PWI value by changing the recipe speeds and temperature set points to the recommended values. How the new changes will affect the different parameters of the process window will be displayed. For example, as shown here, the reflow time. This concludes the basics of profiling level 3, where we learned how to analyze the kick thermal profile data, manage your profile graph, and master Navigator, the process optimization tool. Thank you for watching this video. If you'd like more information on our products or have any questions, please go to our website, kickthermal.com. Thank you, and we appreciate your business.